Sri Chaitanya Bai Knowledge Hub. I, Harish Sen, Senior Physics Faculty. Today we are going to start with differentiation. So in the series of basic mathematics, we started with functions, then we did trigonometry, straight line, and today we are going to do an important topic, that is differentiation. And this topic is new. So what do I mean by new? This topic you did not study in your lower classes. It is going to be a very new topic for you. So I request each and every one of you to pay attention and understand this topic in great detail, because this topic will lay the foundation for physics. It will be used everywhere in class 11th and class 12th. In class 11th and class 12th, teacher will say that we will differentiate the function now. We will differentiate velocity, we will differentiate acceleration. Okay, so this is a very important concept, so please pay attention. So without any further ado, let's start. So first, what is differentiation? So let's say in this first example, as you can see, I have a car, right? Let's say you are going to go to your metro station, and you see that the metro station you see that the train is stationary first. And so let's say that if the train is stationary, its speed is 0. And let's fix the origin at that point. Let's take that point as a reference, the metro station to be a reference. Now, when the train starts moving, from our reference point, the train is moving. So we can say that the position of the train has changed, right? And why has the position of the train changed? Because it has started moving. So similarly here, look here, a car was initially stationary and it is moving towards right with some speed. So let's say this is the metro station. Just give me 1 minute. So let's say this is the metro station. Now here the train will come. So its speed, if it has to stop here, right? It has to stop here when it reaches the station. So what will happen? Its speed will now decrease. Since this speed is decreasing with respect to time, so that is some change, right? The speed is changing with time, as we will say that the speed is changing with time. Similarly, when the train leaves the station, it will slowly gain speed. So I will say that the train is gaining speed, right? So, or there is a positive change in my speed with respect to time. Similarly, look at this example. I can see a small plant, right? I have just planted. If you look after 3-4 months, what will happen? It will grow to some height. After a year, it will grow to some other height. So what is happening here? Here the height is changing. The height of the plant is changing with respect to time. So what is the concept I am trying to say? The concept here that I am trying to deliver is that there is one variable that is changing with respect to other variable. So that is basically differentiation. So when we talk about differentiation, we talk about change of one variable with respect to other. Let's move forward. So what is a function? So let's first recap function. So in a function, let's say this is some box, and in this box I give some input. Let's say this input is x, and this box or this machine is f, right? And it takes input as x and give me some output, and that output is y. So I'll tell that the function f takes input x and gives me output y, right? So x is my input variable, y is my output variable. So what will happen? So as I keep on changing x, my value of y will change, right? Similarly, look here. So here in this example, what is happening? With respect to time, the height is changing. So I can say if I want to write a function here, I'll say the height is a function of time. Why? As the time changes, the height will change, right? Now, so concept of slope. So what is a slope? So if we tell slope is some inclination, right? We have already discussed this in brief in the topic straight line. So if we talk in this, let's first mark a point here. So a point lying on the straight line is this point. Let's say this point is x1, and corresponding to that the output value is y1. Now let's say if I move to some point x2 on the straight line, corresponding to that I will get some output value y2. So what is the change in x we have had here? So can I say that this was the change in x, right? And that change is x2, because this is whole x2 minus x1. So this length will be x2 minus x1. That is my change in the x, or my input variable. Similarly, if I talk the change in value y, that is my output variable. So this is basically my y2, and I will subtract this y1, so I will get this as y2 minus y1. So what was differentiation? Change of one variable with respect to other, or I will say the change of output variable with respect to input variable. And if you remember, what is this? This is basically my slope, right? This was the slope of my straight line. So if you take any 2 points on the straight line, you will get the slope, right? So here we can say for a straight line the slope is constant, or we can say the rate at which my output variable changes with my input variable is constant. Clear? Now let's move forward. Now this is not a straight line, right? This is not a straight line. This is some other function. So let's talk about this function. So let's take a point x1 here, and corresponding to that I will have some value y1 here. Similarly, if I take some point y2 here, x2 here, corresponding to that I will get some output value y2, right? Now, so if you see closely, is the slope here constant? So let's say for if I move some delta x distance in this direction, and I will have some delta y change here, right? So if I again move some delta x distance here, will I have the same change in y? Will I have the same change in y? Please think about it. What I am trying to say that if I move again some delta x, will I have some same change in y or no? So those of you who say that they will have a same change, you are incorrect. See, it is not a straight line now. Okay, this is not a straight line. Okay, so if I move some delta x distance here, okay, the change in y is very less, right? Corresponding to this, if I move same delta x here, the change in delta y is more, right? So here the slope at each and every point is different, or I can say for same change in x, there is a different change in the y. So now what will happen? So we cannot define a slope, right? Why? Because it is changing. So we will define an average slope. So what do you mean by average slope? So when I say average slope, I mean to say that I am assuming this to be a straight line. This is not a straight line, but I am assuming, I am saying average. So let's take an example. So let's say I want to go from Delhi to Mumbai and I travel by car. So let's say Delhi to Mumbai, okay, Delhi to Mumbai is, let's say it is 1200 kilometers, okay. I don't know what is the exact distance, but let's say it is 1200 kilometers. And the time I take is, let's say, 12 hours, right? So if you tell me what was my speed, so my speed, you will say change in distance upon change in time, right? So change in distance or the distance traveled was 12 kilometers, 1200 kilometers, and the change in time was 12 hours. So this will come out to be 100 kilometer per hour. So here the velocity is coming out to be, or the speed is coming out to be 100 kilometers per hour. So does that mean that I was traveling at a constant speed of 100 kilometer per hour? No, yes, I was not traveling for the whole time, for the whole journey from Delhi to Mumbai. Was I traveling at a speed of 100 kilometer per hour? Obviously no, right? I would have stopped for petrol, for food, right? In the traffic, I would have decreased my speed. On the highway, I would have gone fast. Yes. So this 100 is the average speed which I got. So similarly, look here. If we compare this with this, so what is delta y? Delta y is basically my velocity. Okay, change in distance upon change in time. Okay, change in one variable with respect to other. So delta y, the distance upon delta t, delta y upon delta x. So this is what I mean by average slope. So for a non-uniform curve, okay, we will talk about average slope. Okay. So now what I am trying to do, so look at this diagram. So now let's talk about a very small change. Okay, so this delta x, right, is some finite distance I am traveling in x direction. Similarly, I got some finite change in y. Now let's take that delta x to be very small. Okay, if I take this point at this point only, okay, very close to this, I take x1 very close to x2. Look here, if I take x1 very close to x2, so that delta x will become 0 and delta y will become 0, right? Yes or no? Very close, okay. This is my x1 and this is my x2. Now you are saying, sir, that x1 and x2 is a different part. No, it is very close, okay, you cannot see with your eyes. So in that case, this delta x will become 0 and delta y will also become 0. Yes. So in that case, the slope should become delta y upon delta x, that is 0 by 0. And what is 0 by 0? That is not defined, right? You cannot divide any number by 0. So we are stuck here. So what to do now? For a straight line, we can define a slope very easily. For a curve, we can define a slope, right? We can define a slope, average slope. But if that change is very small, now what about that? So if that change is very small, okay, so this change is very small. As I told you, this change is very small. Similarly, there will be a very small change in y. I am taking at a point, okay. So what we are trying to do is trying to find the slope at a point. If I take x1 and x2 be very close to each other, so they will basically form a point, right? So x1 is very close to x2. So this change delta x and this changes delta y. So now if we try to write the slope, I will say the slope is delta x, delta y upon delta x. But for a very small change, we substitute this delta with respect to d, with d, and this delta also with x. So now what does d means? So if I write d, d means a very small change. Now I wrote dy, so dy will mean a very small change in y. Dx will mean a very small change in x. So let's write it down. Dy, a very small change in x, change in y, a small change in x. So what is slope now? Change in y with respect to x, right? Change in y with respect to x. So basically we boil down to finding the slope at a particular point, right? Initially if we started with finding the slope using 2 points. These 2 points are far apart. Then we took this curve, this is a straight line, then we found the slope for a curve, and slope for a curve is changing every time, right? So if the slope is changing every time, we will define an average slope. Now the third, what did I do? I took the point x1 and x2 very close to each other. In that case, delta y and delta x both were 0. So if delta x and delta y both are 0, I cannot define a slope. But here, then also I told you that okay, delta x now I am writing as dx and delta y I am writing as dy. Okay, so let's write now. So let's try to find. To find the derivative of a function fx, we will use the slope formula. So what is the slope? Slope is change in y coordinate. Okay, so I think this is wrong. This will be change in y coordinate upon change in x coordinate. This will also become delta y upon delta x. Or there is some other way to write. Okay, we can also write as limit x tending to 0, delta x tending to 0. What is delta x tending to 0? The change in x tending to 0. At that point, I am defining my slope. So this will be delta y upon delta x. So what does this mean? This means that limit, we are limiting my x, and x I am limiting to, it tends to 0, means that delta x is not 0. Delta x is not 0 basically, but it is very near to 0, right? A very small change in x. Now, so let's try to find the slope of the function x square at any point x using this formula. So the formula is same. So let's first take point x1. Okay, so for point x1, see, so x and y. So for some input x, I am getting my y as x square. Now if I move to some point x2, that point x2 is x plus delta x. So corresponding to that, my y will become x plus delta x whole square, right? That is, if I substitute instead of x, I put x plus delta x. What is delta x? A very small change in x. Now, so let's define the slope. So slope is given y, change in y upon change in x. What is change in y? Let's write change in y. That is x plus delta x whole square upon, and what is change in x? Change in x is, so this was y final, y2 minus y1. y1 is x square upon x2. What delta x? That is x2. x2 is x plus delta x, and what is x1? x1 is x. So let's write this. So can I use the formula? So let's open this. So I'll get a square plus b square plus 2ab, and I am writing minus x square here upon. This will become x plus delta x minus x. So I will get a delta x here. So this x square cancels with this. So what do I get? I get delta x whole square plus 2x delta x, right? Now upon delta x. Now let's take delta x common. So what do I get? If I take delta x common, I get delta x plus 2x upon delta x. Now look here, delta x is very small, right? A very small change in x. So 2x plus delta x will give me 2x, and this delta x cancels by the delta x. So what do I get? I get 2x as my final answer. So at any point x, the value of the slope for my curve fx equals to x square is 2x. So now what is 2x? X is some input variable. So let's say I want to find the slope at x equals to 1. So at x equals to 1, I'll put x equals to 1. So at x equals to 1, the slope will come out to be 2. If I want to find the slope at x equals to 10, so I'll give x equals to 10 here as an input. So I will get the slope as 2 into 10, that is 20. So now we find the slope for the function f equals to 2x square at each and every point of x. Now this is a function f equals to x cube. Please do the same, please pause the video and do the same exercise by yourself. You will find that the slope m comes out to be 3x square. So if I give my input as x equals to 1, what is the slope I get? I get the slope as 3x square. Sorry, 3 into x square, that is 1 square, so 3. So we have defined a formula for the slope, right? So now we will not do the same exercise for each and every function, right? There are millions of functions: sine, cos, trigonometric functions, log functions, exponential functions, quadratic functions, linear functions. So for each and every formula, for each and every function, it is not possible to do the same exercise every time. So some basic trigonometric some basic formulas have been defined. So some derivatives of some common functions. So what do you mean by derivative of common functions? Some functions which are very common in use. So we have done the same exercise for each and every function, and we have wrote here so that it is easy for us to use. So let's write all the functions and find the derivative of them. So I'll not be deriving the derivations, okay? We will just write the functions and the derivative of that function. So first is a constant function. So what do you mean by a constant function? So any function, a constant function is a function which does not change when I change the input, right? So let's say y is equal to 2. So now let's say if I put x equals to 0 as my input, what do I have as my output? Y equals to 2. If I change my input x as 3, what is my output? Y equals to 2. So can I say that this is a constant function, right? So this is a constant function. So in a constant function, so if we look at the definition, right, what is slope? Change in y upon change in x. So is my y changing? Right, my y is not changing. If you look closely, y is always equal to 2. So there is no change in y if I change my x. So what do you see from here? You see that the slope at each and every point is 0. So differentiation. So let's say y equals to k. What is k? K is some constant. K is some constant. So for y equals to k is some constant function. What will be the derivative? So let's write the derivative. So change in y with respect to x, or I'll write derivative of my function y with respect to x, or change in y with respect to x, derivative of my function k with respect to x. Please note that when we talk about change, we talk with respect to something, right? If I say I am happy today, okay, I will be referring with respect to some, with respect to yesterday, or with respect to 1 month before, right? So if I say today is hot, so when I say today is hot, what do I mean? I mean by I am referring to a day before, okay, or or this week, right? So there is always with respect to something. So similarly, we are talking about change in y with respect to x. So what is the derivative of this function? I'll say this is 0. I hope it is clear. So what do you have to note? You have to note that the derivative of a constant function is 0. Let's move on to the next. So let's say if I have a linear function. So what do I mean by a linear function? So y equals to ax plus b. This is defined as a linear function, right? So the derivative for a linear function, so see, I can break this function in two parts. One is ax and one is a constant. We already know that this constant will not change, right? So let's find the slope. So m will be equal to a x plus delta x plus b. So this is basically my y2 minus y1. y1 will be ax plus b upon, that is change in my x. So x plus delta x, x2 minus x1, right? So let's find this. So what will I get? I'll get ax plus a delta x plus b minus ax minus b upon, I'll get x plus delta x minus x. So I will get a delta x here. So if you look closely, delta ax cancels with ax and b cancels with b. So what do I get? I get a delta x upon delta x, that is equal to a. So what is the derivative of this function? The derivative of this function is, so if I write the derivative of this function, dy by dx, or d ax plus b, derivative of my function with respect to x is equal to a, right? Derivative of my function is a. So let's do a small question. So let's say I wrote a question, my function is y equals to 2x. So if I have my function y equals to 2x, so if I want to find the derivative of this, so what will be the derivative of this? So please pause the video and try to think. Okay, now look closely. So this function I can write as ax plus b, right? If I compare with ax plus b, I can say that the b is 0 and a is 2. So derivative of my function with respect to x is equal to a, and what is a? A is 2, right? So this is the way we will apply the differentiation formula for a linear function. So I request you to please keep these formulas in mind. They are very important because you cannot do this exercise every time, okay? If you remember, you will be able to solve this very easily. And for complicated functions, this exercise will become very difficult. As you move forward, you will look through it. Now, a power function. So let's say I have a function y equals to a x raised to n plus b, or just write ax raised to n. Let's just write x raised to n. So if I want to find the derivative of this function, so what is the derivative of this function? So dy by dx, differentiation of y with respect to x. differentiation of y. What is y? X raised to n with respect to x. Change in y with respect to x will be equal to. So in this formula, this n comes forward. This n comes forward and I write x raised to n minus 1. This is the formula. You have to remember this. Differentiation for a power function. We will be solving questions regarding this. But for now, please write the formula. So let's solve one question. So let the question be, find the differentiation of y equals to 4x 6, 4x raised to 6. So the differentiation of this formula is dy by dx is equal to. So now, for now, let's remove this 4 also. For now, let's remove this 4 also. Okay, we'll do that later. So my function is y equals to x raised to 6. So what happens? The n comes forward. So the n will come forward. I'll write x and I'll write n minus 1, that is 6 minus 1. So I'll get 6 x raised to 5. So this is my derivative for my function y equals to x raised to 6. Right? I have used the power formula to find the derivative of that function. Let's move on. Exponential function. So what are exponential functions? Any function of the form a raised to x are known as exponential functions. Right? So now what is the derivative of exponential functions? So y equals to a raised to x. So the derivative of a raised to x is dy by dx is equal to a raised to x ln a. Right? A raised to x ln a. Now if I substitute this a with e, if I substitute a with e, so y equals to e raised to x. So dy by dx will be equal to, just substitute a with e, right? A with e. So I get e raised to x and ln e. And what is ln e? Ln e is 1. So I get dy by dx is equal to dy by dx, that is differentiation of e raised to x with respect to x is e raised to x itself. Please keep this formula in mind. What about logarithmic functions? So what are log functions? Log x base a is known as a log function. Any function of the form log x base a is known as log function. So what is the differentiation of this? So dy by dx, or differentiation of log x base a with respect to x is equal to 1 upon x ln a. 1 upon x ln a. Please note that when I am talking about differentiation, basically I am referring to change in x, or change in x with respect to y, or change in y with respect to x. Okay, if we just flip this, this will become change in y with respect to x, right? Sorry, change in x with respect to y. Now, in this case, if I substitute a equals to e, so what do I get? I get y equals to ln e, ln x, right? So differentiation of ln x, so differentiation of ln x with respect to x will be equal to, so let's put a equals to e. So a equals to e, I'll get 1 upon x ln e, and ln e is 1. So I get differentiation of ln x is 1 upon x. I hope this is clear. Now, last, trigonometric functions. So there are 6 trigonometric functions, right? T ratios basically. So first, for differentiation of sine. So let's say y equals to sine x, right? So differentiation of sine x with respect to what is my input variable? X, right? So differentiation of sine x with respect to x is cos x. Second is my cos x. So y equals to cos x. So differentiation of cos x with respect to x is minus sine x. Going forward. Now y equals to tan x. So differentiation of tan x with respect to x is sec square x. Differentiation of cot x. So differentiation of cot x with respect to x is equal to minus cosec square x. Y equals to sec x. So differentiation of sec x with respect to x is minus sec x tan x. Similarly, if I have y equals to cosec x, so differentiation of cosec x with respect to x, differentiation of cosec x with respect to x is equal to minus cosec x into cot x. So these are the 6 formulas to find the differentiation of trigonometric functions. And all these formulas which I wrote here, so let's count the formulas. So first one formula, right? So first was my constant function. So constant function differentiation is 0. For a linear function of the form y equals to ax plus b, the differentiation is a. Second formula, this is the power formula, that is my third formula. This is my exponential formula, that is my fourth. This is my fifth formula, and 6 formulas here, that is total 11 formulas you have to remember. So if you remember these 11 formulas, you can easily do differentiation of any function. We have not covered every function here, but using these formulas, we will be able to find the differentiation of each and every function. So let's talk about the different functions which we have. So before finding the differentiation of all the functions, for any function, let's first discuss some rules used in the differentiation. So first rule, rules for differentiation. So multiplication of a function by a constant. So what is the rule here? So let's say I have a function y equals to f of x, and I find the derivative of that function. So let the derivative of this function y for is, let's some function gx, okay? I did the differentiation of y and I got of this fx and I got gx as my output function. So now if I multiply this function y with respect to some constant, let's say k. So now my new function is y equals to kfx. So what is the differentiation of this function? So the differentiation of this function dy by dx will be equal to k into differentiation of fx. We keep this constant as it is and we just differentiate the function fx, and we know that the differentiation of function fx is gx, so we get a gx. So to understand this by an example, let's write an example to understand this function, this property. So let's say I write a question that y equals to 2 x raised to 6. right? It is the same question which I gave you before in the power formula. So here I have a constant multiplied with my function, right? This is basically k and this is some fx, right? So y equals to kfx. So what happens? We keep the k as it is. So to find the function, differentiation of this function, I will write dy by dx equals to, just write the k as it is and differentiate fx. So differentiate fx, that will be my gx. Now, so what is k? K is 2 and differentiation of x raised to 6. So to find the differentiation of f raised to 6, what is the formula I use? I use the differentiation of x raised to n, that is the power formula. So x raised to 6. So what happens? N comes forward, now write x raised to n minus 1 and I subtract a 1. So 6 will come forward, I will write x raised to 6 minus 1. So what do I get? I get 6 into x raised to 6 minus 1. 6 2s are 12 into x raised to 5. So this is the derivative of my function y equals to 2x raised to 6. I hope this is clear. The first rule is clear to you. Now let's move to the second rule. Differentiation of sum and difference of a function. So in this, I will have one function fx, I will have some function gx, and these both functions either will be in sum form or they will be in a difference form. Function 1 minus function 2, fx minus gx. Let this function be hx. So if I have a function like this and I want to differentiate the function hx, differentiation of hx with respect to x. So in this case, what do? If I have sum of two functions or difference of two functions, then I differentiate both the functions, right? I differentiate both the functions one by one and just write the sign as it is. So what do I get? So I'll differentiate my function d f of x with respect to x. I'll differentiate my second function with respect to x. And I'll write whatever sign is in between them. So what is the rule? Just differentiate the function as it is. Okay, one by one, and just write the sign which was there before. So let's do a question. So here I have function 1, function 2 and function 3. So I have my first function fx. So let's write the first function. So let's write this 6x as my function 1. My function 1 is 6x cube, right? So differentiation of 6x cube is 6, right? Differentiation of my function, just 1 minute. So my function 1 is 6x cube, right? So differentiation of function 1 with respect to x is, which formula I will use? I will use the formula power formula and the first rule, that is the multiplication by a constant. So this constant will remain as it is, this 3 will come forward and I will write x raised to 3 minus 1. So I will get 18x square. So differentiation of 6x cube is 18x square. Similarly, this is of the form ax plus b, and differentiation of ax plus b is, right? So ax plus b. Okay, so I will get an a and this b becomes 0. Or I can also write that the differentiation of 9x is 9 and differentiation of 4 is 0. So this is how I find the differentiation if two or more functions are in addition or subtraction. I differentiate them individually and just add them up. let's move on to the next question. So now look here, there is no x. So will we be able to differentiate? Yes. Okay, we don't need x here. Why we don't need x? Because here my input is t, right? See, it is not dy by dx every time. It is change in my output variable with respect to my input variable. So what is my input variable here? My input variable is t and my output variable is y. So here I will talk about change in my output variable with respect to my change in my input variable, right? This formula, the formulas which we wrote are not applicable just to y and x. Okay, y and x is just representing my output and input variable. So this is my output variable, this is my input variable here. So what is the differentiation of 2t raised to 4? This 4 will come forward, so 2 into this 4 will come forward, and I can write t raised to 4 minus 1. For my 10 raised to t, so 10, this 2 will come forward and I'll write t raised to 2 minus 1. And lastly 13t, so 13t is 13. So what do I get? I get 8t cube minus 20t plus 13. So this is my final answer. I hope this question is clear to you. If you have any doubts in this question, please go to the previous slide and look what did I explain there. Okay, please try to work it out. I have gone a bit fast in this question, but you have to learn the differentiation in this way. You should be able to differentiate a function very fast. You should not take too much time. So please solve questions for differentiation. Now, what about this question? So here, what is my input variable? My input variable is z. And what is my output variable? My output variable is rz. Okay, your function is not fx, your function is rz. Now, what can I write? 6. And this is x root of x cube. So root of x cube I can z cube, so I can write z raised to 3 by 2. Similarly, I can write here 1 upon 8 into z raised to 4 and minus 1 upon 3 z raised to 10. Right? Now, so now I will take the 6 into z raised to minus 3 by 2 plus 1 by 8 into z raised to minus 4 and minus 1 by 3 into z raised to 10. Right? So now this is some constant into some function, some constant into some function, some constant into some function. And which formula I can use? I can use the power formula, right? X raised to n, z raised to n. Why z? Because z is my input variable here. So if we try to solve it, I'll get 6 into, I can write, so differentiation of, so this is basically rz only. And I am here starting to, I will differentiate the function here. So differentiation of my function rz with respect to z. So what do I get? 6 into, this n will come forward and I will subtract minus 1 from n. Here 1 by 8 into, this n will come forward and when I will subtract minus 1 from it. Similarly, here also this n will come forward and I will subtract minus 1 from it. Right? So this is my final answer. Please do the calculation and find the answer. I hope this question is clear to you. Now let's move forward. Now product rule. So what do you mean by product rule? In product rule, 2 or more functions are in multiplication form. So let's say I have a function fx and I have a function gx and they are both in a multiplication form. that be kx, hx. So if two functions are in multiplication form, so what do? We take one function, we take second function, we name the function 1 and 2. Now, what is the formula for this? So differentiation of hx with respect to x. Now what is hx? Hx is a function which is multiplication of two different functions. So what is the formula? In this formula we keep one function as it is. So keep one function as it is. And I'll differentiate the second function. So I'll differentiate the second function. Plus, now I'll differentiate the first function. And I'll keep the second function as it is. So this is how you differentiate when two functions are in multiplication form. So let's understand this by doing a question. So I have a function 1 here. This is my function 1 and this is my function 2. I have two functions in multiplication form and I want to find the derivative. So what did I tell you? I told you to first differentiate my first function. So differentiation of my first function. And I'll keep my second function as it is. Plus, now I'll keep my first function as it is and I'll differentiate my second function. So what do I get? So differentiation of 4t square. So differentiation of 4t square is this 2 will come forward. So 4 2s are 8 into t. And differentiation of t is 1. I'll write my second function as it is. Plus. Now, I'll write my first function as it is. And I'll differentiate my second function. So my second function is 3t square minus 16t plus 0. Right? This 3 will come forward and I'll subtract 1. So I'll get 3t, 3 minus 1, that is 3t square. Minus 8t square, this 2 will come forward. So I'll get 8 into 2, 60 and t raised to 2 minus 1, that is t. Plus differentiation of a constant 12 is 0, right? So this is my final answer. So yeah, I am not doing any further calculations because my main aim is to solve differentiation, to find differentiation, okay? This calculation part you can do it by yourself, but understand the concept, the product concept which I am trying to apply here. Here I am trying to find the differentiation of two functions which are in multiplication form, right? Function 1 and function 2. Now, let's talk about this function. So, in this question, what do I have? So, if you look closely, I have function 1, sin x is my second function and I have cos x as my third function. So, now there are three functions, but in product rule, we only have two functions, function 1 and function 2. So, we have a problem here. So, how to solve this now? So, we will use some trigonometry knowledge. So, if we know that what is sin 2x? Sin 2x is 2 sin x cos x, right? So, I can write sin x cos x as sin 2x by 2. So, the function now fx becomes e raised to x upon sin 2x by 2. So now I have a function 1 and I have a function 2. But here we have a problem. What is the problem? For function 1 I can differentiate very easily. The differentiation of e raised to x is e raised to x. But differentiation of sin 2x will be equal to cos 2x. No, differentiation of sin 2x is not equal to cos 2x. It is some another function. So we learn how to differentiate sin 2x using the chain rule. Okay, we will differentiate using chain rule. So once I complete the chain rule, please come back to this question and you try to solve it. Let's move on to the next part. So division rule. So in division rule, what do I have? I have two functions, fx, another function is gx, and both functions are in division form. Let this be hx. So now if I want to find the derivative of my function hx with respect to x, so what is the formula? So now I have a trick here. What is the trick? This is basically a numerator and this is a denominator, right? So this numerator I can write nurse and this as doctor. So I know is as a nurse doctor formula. So let's take a situation here. Let's say suppose I am ill and I go to a clinic. So if I enter a clinic, who do I see first? I see a nurse first. So first I'll differentiate the nurse, that is the numerator. So I'll differentiate the numerator and I'll keep the doctor as it is, right? I'll keep the doctor as it is, minus. Now after that the nurse will make some slip for me and send me to the doctor, right? So she will send me to doctor. So now and then the nurse will sit idle, right? So keep the nurse or the numerator as it is and the doctor will now look to me. So I'll differentiate the doctor now. Upon who will take the money, right? The doctor will take the money. So just write gx square, right? This is the formula. This is the way I remembered the formula. So I told this trick to you. You can use any other trick. So this is the formula. So what is the formula? Differentiate the numerator and keep the denominator as it is, minus keep the numerator as it is, differentiate the denominator upon denominator square. So if I have two functions in division form, I will use this formula to find the differentiation of the function. So let's do a question here. So this is basically my fx or my numerator and this is my denominator. So let's find the differentiation of the function. So differentiation of gx with respect to x is equal to, first function differentiate my numerator. So if I differentiate my numerator, okay, first differentiate the nurse. So I'll get 6x square, that is the 2 will come forward, I'll get 6 into 2 into x raised to 2 minus 1 and keep the doctor or the denominator as it is, minus. Now I'll keep the nurse or the numerator as it is and differentiate the doctor. So 2x, so differentiation of 2 is 0 and x is 1 upon, who will take the money? Doctor will take the money. So I'll write the denominator square or the doctor square. So what do I get? I get 12x into 2 minus x minus 6x square minus 1 upon 2 minus x whole square. So this is my final answer. I hope this differentiation formula is clear to you by this example. Let's look at this question. So tan x, my function fx, is basically tan x, and I can write tan x as sin x cos x. So this is my first function, that is my numerator, and I have my second function, this. So let's differentiate this function. So differentiation of sin x. So differentiation of fx with respect to x will become, so differentiation of sin x will be equal to cos x, and I'll write cos x as it is, minus, now I'll write the numerator as it is and I'll differentiate the denominator. So differentiation of cos is minus sin x upon, I will write denominator square. So this will become cos square x plus sin square x, and cos square x plus sin square x will become 1 upon cos x square. And what is cos x square? That is sec square x, because 1 upon cos is sec. This will become sec square x. So differentiation of tan x is equal to sec square x, and we have already written the formula that the differentiation of tan x is sec square x, right? So this is a proof of that function. So this is how you use the function tan x, the division formula, to find the differentiation of functions which are in division. So we will finish today. Tomorrow in our next class we will study about chain rule and the applications of differentiation. The two applications of differentiation are to find the slope and maxima minima concept. So please do join in my next session so we can finish the differentiation part and move on to the integration part. I hope you are all enjoying the physics and the differentiation. I know it might be boring to you to learn this math part, but trust me, if you know this math part, the physics will become that much interesting, because at that time you will only be understanding the concept, because math you already know. But if you don't study the math now, afterwards you will have to study maths and that will become very boring. So please, as I do the questions, you also do the questions, and the worksheet is given in the description box below. So please download that and start solving questions, because question solving is the key. The more questions you solve, the more good you will become at it, right? So please join in my next session. Thank you. I hope you enjoyed it. If you have any doubts, please write in the comment section. Thank you. एक घंटा हो गया आज भी.